Hey guys, Mr. B here. So in this video, we're going to be going over the chapter 10.3 notes on percent composition. We will not be talking about empirical formulas. So there is a section of this chapter that I have cut out just to make it shorter and to make the material a little bit easier for you. So, all right. So in this section, we're going to be talking about percent composition. And percent composition is basically exactly as it sounds. It breaks down the composition of a material based on its weight and the different percentages of each material in that substance by weight. So if you ever seen like a picture of or if you ever seen like a tag on a shirt, you may see that it says, like 66% cotton, 34% nylon. Or, it gives you information about how much of that material is made out of, different things. And a lot of that is because it will determine what kind of properties that material has based on the stuff that's in it, right? So, for example, if you have something that's primarily made out of cotton, right, based on weight, you may know then like not to wash it in warm water and then dry it because it'll shrink on you, right? So, this especially in chemistry can help us to understand different properties that materials may have if we know what they're primarily made out of. Okay. Again, there are some key equations here, which again is just the math work behind how we do some of this stuff. If you're an equations person, then maybe you can write these down and remember them, but otherwise I'm just going to show you how to use these things in a regular sense. So, all right, so let's get into percent composition. So how do we calculate the percent by mass of an element in a compound? So here's a breakdown real quick of two different compounds. One is potassium chromate, the other is potassium dichromate. Okay, and each of these little pie graphs shows what percentage by mass is each of these compounds made up of: potassium, chromium, and oxygen. So we can determine these percentages by finding the mass of each element individually, okay? And that mass will come from the periodic table, so it's molar mass. We take the mass of each of those elements and we divide that by the mass of the entire compound, and we times by 100. So basically what we're doing here is we're finding the molar mass of potassium, the molar mass of chromium, and the molar mass of oxygen, and all the potassiums and all the oxygens, okay? So not just one potassium and one oxygen. So we're finding all the individual masses of all these elements, and we're adding them all together to get the total molar mass of the whole compound. Then we're taking the mass of just the potassiums and dividing that by the total, and then timesing 100. Or we're taking the mass of all the oxygens or just the chromium, and then dividing that by the total mass and timesing by 100, and that will get our percentage breakdown. And if you look at both of these these compounds here, in potassium chromate, potassium makes up a very large percentage of the compound, but in potassium dichromate, we've essentially not changed the number of potassiums, right? So between potassium chromate and potassium dichromate, they both have just 2 potassium atoms. But in the regular chromate compound, there's 1 chromium and 4 oxygens. In the dichromate, there's 2 chromiums and 7 oxygens. So we've essentially increased the mass of this whole compound by adding more chromiums and oxygens. And the total number of potassiums did not change, which means it makes up less of a percentage of the whole compound than it did in the regular chromate compound. Okay, so we're going to go through some examples here to see how this really works. But we're using regular percentages, just like you would do on like a test or something to determine your percentage. So the relative amounts of the elements. The relative amounts of the elements in a compound are expressed as percent composition, or again, it is percent by mass of each element. So this is the key part to realize is we're finding percent by mass. We're not finding percent by count. Okay? So what that means is so for example, we're going to shift this up here just so we can type below it. So for example, if I asked you what is the, let's just do this in red so that it stands out better. So what is the percent of H in H2O? Okay. If we were doing percent by count, you might go, well, there's 2 H's and 1 O. So H is 2/3 of H2O, and 2/3 as a percentage is 66%. So therefore H makes up 66% of H2O. Right? Like, that would make sense if we were determining percentage by count. But we're not. Okay? We're determining percent by mass. So all of this is wrong. Okay? Instead, we would again say, so what is the mass of, or sorry, what is the percent of H in H2O? We first need to know the mass of just the H, just the O, and the whole compound. So the mass of H2 is 1 gram a piece times 2. Okay, so hydrogen has a molar mass of 1. That's on the periodic table. I didn't pull a periodic table here for this, but it's pretty easy. That one's an easy one to remember. Okay. And as for oxygen, oxygen has a molar mass of 16 grams. So the total mass, of H2O is about 18 grams per mole. Okay. If we want to know the percentage of H, we would take the mass of the H, which is 2 grams, and divide that from the mass of the whole compound, which is 18 grams, roughly, times 100 equals. Okay? And this would tell us what percentage of H makes up water by mass, not by count. Okay? So we can do this real quick on a calculator just to get a number. So we can take 2 divided by 18 times 100, and then just rounding whole numbers, we get about 11%. So about 11% of water is essentially hydrogen, and the other, 89% is oxygen. Okay, so this is what we're talking about by percent composition. So let's take a look at an example problem here, so it will make a little bit more sense, and then we'll go from there. So, all right. So this problem says, when a 13.60 gram sample of a compound containing only magnesium and oxygen is decomposed, so decomposed means it's breaking apart, okay? 5.40 grams of oxygen is obtained. What is the percent composition of this compound? All right. So I'm going to just kind of write out some stuff here to sort of help you visualize what's going on. So we have 13.60 grams of this MgXOY compound. Okay, so we have 13.60 grams of this material. We don't know the chemical formula for it, and it's breaking apart. Okay, so we're going to get some amount of grams of magnesium. Okay, we don't know how many grams. We have to kind of figure that out. And we're also going to get 5.40 grams of oxygen. Okay, so this, and I guess it's technically O2, which is diatonic, but that doesn't matter. So, all right, so this is what's happening. And the question, of course, is what is the percent composition? So what percentage of this is magnesium? And what percentage of this is oxygen? Okay? All right. So this one, we don't need to find a molar mass because we don't know the chemical formula. But we already have a total mass because they're giving it to us right here. So we can just take the mass of each element given in the problem divided by the total times 100. Now for the oxygen, we already know what that is because they gave it to us. So we would take 5.40 grams of oxygen, divide by the 13.60 grams of this compound, and then times that by 100 to make it a percentage. Okay? So if we do this, and I'll do it on my calculator here real quick so that we can get a good answer. So 5.40 divided by 13.60 times 100. And we're just going to round to, let's just go 3 sig figs. So 39.7% oxygen. Okay, so there's that percentage. That's how much oxygen is in the compound. From here, we could do one of two things. One, we could just take 100% minus 39.7%, and the difference will be the magnesium. Okay, that's one way to solve for it. Or, because of the law of conservation of mass, if 13.60 grams was our total for the whole thing, And when it breaks apart, we make 5.40. We could subtract 13.60 from 5.40, and the remaining grams would be how many grams of magnesium we have. And then we could do this whole thing like we just did here with the magnesium mass and get percentage that way. Either one works just fine. I'm just going to take 100 minus 39.7 because it's just a little bit faster. Okay, and again, the difference here is going to be the magnesium percentage. So we get 60.3% magnesium. Okay, so all of the percentages that you calculate should add up to 100%, or very close. Now, granted, they might be like 99.9 or like 100.1 or something like that, or a little bit off, and that's just probably because of rounding. But you shouldn't be getting like 97, 96, 103, 105. You messed up somewhere if you're getting percentages that are that high. So, or when you add them together, if they're over 100 or under 100 by quite a bit. All right. I'm not going to be going over the problems here. I have a video of me going over the practice problems. So again, if you want to watch that, you can, to hopefully clear up some confusion. I'm just going to keep moving on to go over these other example problems and the rest of it. So we can use percent composition from the chemical formula as well. The previous problem we did was getting percent composition from like a sample number, or like the amounts of a sample. But we can use molar mass as well to find percent composition. So here's an example. So propane, C3H8, fuel commonly used in gas grills, is one of the compounds obtained from petroleum. Calculate the percent composition of propane. So in this problem, they want us to take this C3H8 and they want us to break it down to tell them what percentage of it is carbon and what percentage of it is hydrogen. Okay, so in order for us to do that, we need to get the total mass of the whole compound, which is going to have to be molar mass. Then we'll take the mass of each individual element, carbon and hydrogen, and divide that from the total. Okay, so first let's figure out what is the mass of 3 carbons and what is the mass of 8 hydrogens. Okay, now I don't have a periodic table here in front of me, but I know these off the top of my head. If you have a periodic table, you might want to pause and just look it up, but otherwise, just take my word for it that carbon has a mass of 12 grams apiece. We're going to times that by 3 because there are 3 of them. So 12 times 3, that gives us 36 grams for the carbon. As for hydrogen, hydrogen is basically 1 gram apiece, so times that by 8 because there are 8 of them. We get 8 grams of hydrogen. Okay, so these are the individual masses. So it means the total molar mass of C3H8 is going to be equal to 36 plus 8. So this is 44 grams per mole. Okay, there's our total. So then to find our percentages, we're going to take the mass of each individual element divided by the total. So 36 grams of carbon divided by 44 grams for the C3H8. And then we're going to times that by 100 to turn it into a percentage. Okay, so take this times 100. Equals, so let's do this out real quick. So 36 divided by 44 and then times 100. We'll just round to whole numbers to make it easy. So 82% for the carbon. So there's that percentage. Then once we have that one, we could just take 100 minus 82 to get the hydrogen. But because I have the mass of the hydrogen right here, we're just going to do the same thing for that one to figure that one out. So 8 grams of hydrogen divided by 44 grams for the C3H8. And then times 100 equals, and then this will give us 18% for the hydrogen. Okay, so this is what they're asking. So that this is the percentages of breakdown for these by mass. Again, we got this by first finding the individual masses of these elements in the compound, adding them together to get a total molar mass, and then taking each individual mass divided by the total times 100 to get our percentages. Okay, so there we go. There's our percent composition from molar mass. All right. Last thing here is we can also use percent composition as a conversion factor. So we can basically calculate how many grams of an element are in a specific mass of a compound just by multiplying the mass of that compound by its percentage as a decimal. So here's the example that they're going to show, and this is actually from the previous problem we just did. So propane is 81.8% carbon. I rounded up to 82. They just took it more specific. So 81.8% carbon and 18% hydrogen. You can calculate the mass of carbon in the mass and the mass of the hydrogen in an 82 gram sample of propane by doing this as follows. So if we take 82 grams of propane and we multiply it by 81.8 grams over 100, so this little part right here that they're doing, this is basically just multiplying by 0.818. Okay, so they're taking the percentage of carbon, which is 81.8%, and they're multiplying it to the total mass of the whole sample as a decimal. Okay, so this fraction here, this 81.8 over 100, that's basically just turning this into 0.818, which is 81.8%, but it's as a decimal. So they're just taking the mass, multiplying it by the percentage as a decimal, and then they're getting how many grams of carbon that would be in that sample, okay, just based on the weight. They're doing the same thing here with the hydrogen. 82 times 18 over 100. This would be the same thing as just multiplying by 0.18. So 18% as a decimal. And then they're getting the mass here for the hydrogens. Okay, so we can use percent composition again as a conversion factor. You just take your total mass, you multiply it by the percentage of that element in the compound by its percent composition, and that'll tell you how many grams of just that element in particular are in the compound. So I'm pretty sure in the lab that you guys, I think, have to do or already did, there was a problem where you had to do this for the candle wax. You had to determine how many grams of carbon were in the candle. So this should be familiar to you either if you've already done the lab or if you're going to do the lab, you'll see this come up then. So, all right, that is it for information in this section. Pretty short one. Again, if you want to see me go over these problems in practice, there's a video on that as well. But otherwise, that is it for this chapter. All right, so the next thing you will have to do is do some review for the chapter before you take your test. And as always, if you have any questions or need help from me, let me know. All right, guys, I'll see you in the Chapter 10 review.